Section, we're going to talk about something called literal equations. So I think this opening actually helps explain why we might want to do it. The volume of a rectangular box is this equation: length times width times height. But there may be times where you're given problems where it's not. Let me back up. Sorry. This form of the equation is super helpful when you have the dimensions of the box, its length, width, and height, and you're trying to find the volume. But there may be times where you're trying to create some boxes or build some boxes, and you know exactly what volume you want, and you know the width and the height you want, but you're trying to decide how long does it need to be if I want to reach this particular volume. So in that case, it's actually helpful to rewrite this equation so that instead of volume being by itself, the length is by itself, because that'll make the calculations a whole lot quicker. You just plug in the volume, the width, and the height, and you're done. You won't have to rearrange the equation every single time you plug in these values. So in the practical sense, this lesson will be helpful for two reasons. One, these are kinds of questions that show up on the SAT, like the national one you take before college, and lots of people get them wrong, even though they're not that hard. It's more so they just aren't used very much. So that'll help you. But also, especially as you advance more in science, there'll be lots of times you have equations about things like pressure or acceleration or gas pressure or all sorts of those kind of things. And there will be times where you're given what's over here and looking for this. There are other times like this where you're given the big picture and then missing one of the little pieces. So rewriting it to be what you need to find as what it's equals to is very helpful. So let's begin. So number one, solve 3x minus 4y equals 7 for y. So what that means is we need to get the y by itself. I know you guys love it when our final answer is just a number, but our final answer is going to be an equation. It's just the equation is going to be rearranged. So our goal is to get the y by itself. Now, there's more than one way you can approach these, so there's more than one form of the answer to be correct, and I'll know that on a quiz or a test. But I'm just going to keep the y where it is, and I'm going to subtract the 3x from it. Now, I can't combine these two because they're not like terms, so I just write it as 7 minus 3x. So now y is nearly by itself. It just has that negative 4. It's negative 4 times y, so to get rid of it, I've got to divide it by negative 4. So my final answer would be y equals 7 minus 3x over negative 4. Now I'm going to come back and do example 2, but example 1 is a lot more like what you'll see most of the time. Example 2 is a little bit of a harder kind, so I want to do some others of the easier ones before I show you that one. So down here it says solve each equation or formula for the variable indicated. So again, what that means on number 1 is I need to rearrange this equation so that x is by itself. So I need to get the x by itself. So I'm a little off focus. Let me fix that. There we go. So first I'll add b to both sides. So that gives me ax equals c plus b. Again, I can't combine c and b because I don't know what their value is. They're not like terms. So I just write c plus b. Now I want x by itself. It's being multiplied by a. So I have to do the opposite and divide by a. So our final answer is c plus b over a. Okay, on number 2, we need to solve this for x. Right now y is by itself, but we need to rewrite it so that x is by itself. So I'll start by subtracting 1 from both sides. Now when we get rid of the 15, it's 15 times x, so we need to divide by 15. So again, the reason this is helpful is if you were told a bunch of x values and asked to find the y's, this form, the original form, is super easy. It's great. Then you just plug it in, multiply by 15, add 1. But if you were given a whole lot of y values and asked to solve for x, if you did that with this equation in this form, you'd have to be plugging in the y, subtracting 1, then dividing by 15, just to rearrange everything every single time you plugged in the y. But now that we have it in this form, we can plug in y a lot more quickly. We know we just plug in the y, subtract 1, divide by 15. It's more clear what to do. Okay, number 3, they try to be a little tricky by putting these parentheses, but the parentheses actually don't mean anything because all we're doing is adding. There's no distributive property going on because there's nothing being multiplied. So if it's helpful, just write it as x plus f plus 2 equals j. So obviously we need to move both the f and the 2 over. It does not matter which you subtract first. It makes no difference. So I'm just going to subtract the f over. And then I'll subtract the 2 over. So I get x equals j minus f minus 2. Like I said, there can be more than one right way to rewrite it. If I had chosen to subtract 2 first and then the f, I would have had j minus 2 minus f. That's okay. That's equivalent to what we have here. So either form is all right. Now number 4, it says 4 times r plus 3 over t. We're supposed to solve it for r. It is truly fine if you want to distribute and solve for r. You will definitely get a correct answer. That's no problem. In my opinion, though, it's quicker and simpler in this case because you're not dealing with numbers anyway, so it's not really going to be complicated if we divide by 4. So instead of distributing, I'm going to choose to divide both sides by 4. Because then I don't need those parentheses anymore. And I've got r plus 3 equals t over 4. So r is having 3 added to it, so I subtract 3 from both sides. I get r equals t over 4 minus 3. Now if you choose to distribute, you'll still get an equivalent answer, and that will be counted right just as much. Okay, number 5, we're solving this for x. So I first want to get rid of the b. So I'll have 2x equals w minus b. Then they're multiplying x by 2, so I need to divide by 2. We get x equals w minus b over 2. Number 6, we want to get x by itself. X is being multiplied by 1 plus y. So we want to divide both sides. You can keep this as a whole unit. Divide both sides by 1 plus y. Because then that cancels it out, and we're left with x equals z over 1 plus y. And if you want to keep the parentheses around 1 plus y, that's fine. It's not necessary, but it's completely fine to do it if you want to. Okay, so I think number 7 is another good example of how this can be helpful. You may not recognize this formula, but this is the formula for converting things from Fahrenheit to Celsius. And again, if the temperature you're starting with is Fahrenheit, this form is great. You just plug in Fahrenheit, subtract 32, multiply by 5/9. But if the temperature you start with is Celsius, it's going to be a lot more complicated to unravel this to get f by itself, especially if you're doing it over and over and over. So this is a great form for the equation if you have Fahrenheit and trying to find Celsius. So we're going to rewrite it so that f is by itself, because that'll make it easy. start with Celsius and with Fahrenheit. So you can get rid of this fraction by multiplying both sides by its reciprocal. So I'm multiplying by 9/5 because then the 9's cancel and the 5's cancel. I get 9/5 C. Then I add 32 to both sides. 32. So we get F equals 9/5 C plus 32. So this is a great form of the same equation that allows us to solve for Fahrenheit when we're given the temperature in Celsius. 8 is similar. We're looking at the perimeter of a rectangle. And if you have the two dimensions of the length and the width, this is a great way to find the perimeter, as you've done for a long time. But there may be times where they tell you the perimeter and the length and ask you to find the width. So if that happens, having W by itself will make things work a lot more quickly. So we want W by itself. We'll subtract 2L from both sides. Then we'll divide both sides by 2. And just one quick side note, it doesn't matter whether your variable is on the right by itself or on the left by itself. It can be correct either way. Number 9 is the formula for area of a rectangle. So we want L by itself, because if you're told the length and width, this is a quick way to find the area. But there may be times where you're trying to pick an area you want. You might want a certain amount of square footage in your home, or in a room, or in a shed, or in even a place you're fencing in for an animal. You know the amount of square feet you want, and maybe just because of your property or because of another room or building, you're restricted about the width, so you plug that in. So you're trying to figure out what length you can do. So in that case, we'll try to get the length by itself. Well, right now, length is being multiplied by width. So we do the opposite and we divide by the width. So we get L equals A over W. Okay, so almost all the questions you face will be like these, but I do want to show you this example too. It's a bit of a challenge. So this, you can see the equation, 3m minus n equals km minus 8. They want us to solve it for m. So take a moment and look and see if you can tell what's different from this equation, or this example, from all the other ones we did. In all the other examples we did, the variable we wanted to solve for, the variable we wanted to get by itself, only showed up one time in the equation. But this time it shows up twice. So you're like, how in the world do I get it by itself if there's two of them? Ah, here comes the magic. So the trick is, you want to get everything with an m, or whatever variable you're solving for is, everything with an m on one side of the equation. That'd be these two. You want everything without an n, an m, that'd be this one and this one, on the other side of the equation. So I'll subtract km from both sides first. So I get 3m minus n minus km. This cancels. I get that equal to, negative 8. So now I've got the two terms with m on the same side, but I've got one I don't want on this side, and that's the n. So they're subtracting n, so I'll add in to both sides. So you might still be saying, well, how in the world do I get one m, or a single m by itself? Because I can't combine these because I don't know what k is equal to. If that was like 3m minus 2m, that'd be great. I could just say that equals 1m. But we don't know what k is equal to. Here's the trick. You kind of do the reverse of the distributive property. It's called factoring. These both have an m in common. So I can write m outside here. If I take m away from this, I have a 3. I keep the minus sign. Take m away from this 2, I have a k. And if you look, we can tell these two are the same thing. Because if I did distribute the m back in, m times 3 is 3m minus m times k is km. So this is the same thing, and if you look, we did have 2 m's, now we just have 1. So m is being multiplied by 3 minus k, so our last step is to divide by 3 minus k. So our final answer is -8 plus n over 3 minus k.